Hello, in this video, we will look at the area of triangles. Now, one of the things I see a lot online is that people say the area of a triangle is like a rectangle because it's half of a rectangle. And yeah, that's true, but it's a special case. So it's not really the reason why we should teach it that way. Let me tell you what I mean by that. So if we look at a rectangle, right, it has all 90-degree angles. And if we take half of a rectangle, it is true that we get a triangle, but we actually get a special case. We get a right triangle. And so that might give you the false impression that the reason the area of a triangle is half of the other of a parallelogram and a rectangle is because it's half of a rectangle. In other words, it's half of that base times height. Well, yeah, true for right triangles, but not true for all triangles. So let me give you a nice example of that. If we were to draw a triangle that was not right, let me make an example. It's easy to make an example of that, right? Let me make a rather obtuse looking triangle right there. How would I double that to make a rectangle? You can see that it doesn't fit nicely in a rectangle. And in fact, if I try to draw a rectangle around it, I might be able to think about how that actually is doubling the triangle, but it's not completely obvious. And if I were to mirror it across itself, I end up getting some kind of image that we call a kite. And so a better way to think about it is if we take any triangle, it's actually half of a parallelogram, as you see in the diagram here. Okay, so if we have a parallelogram, we can see how the triangle would be doubled there in the picture. Now, the way that we can do that with any triangle, like I said before, if we have some obtuse triangle, let me just make an example of one here below, right? If this is our triangle, what is the parallelogram that would describe that? You would need to take that triangle and you would need to sort of mirror and flip it across one of the sides. So if I were to mirror this below, you can imagine me mirroring this below. Like I said, that makes a kite. But if then you were to flip it left to right, if you were to kind of cut it down the middle, that blue triangle below, and flip it across that, what you would find out is that this line gets mapped to over here, all right? And then the other line, the other side gets mapped there, and there's your parallelogram. So it turns out a triangle is always half of a parallelogram. Thus, if the area of a parallelogram is nothing more than the base times the height, then the area of the triangle, maybe I should put parallelogram so you know what I'm talking about right there. The area of the triangle is nothing more than the base times the height, then divided by 2. Sometimes written as 1/2 base times height. Those are precisely the same thing. Look below for a lot more examples.